synthesis, they go hand in hand. Block one, the other stops. It's not immediately obvious why would electron transport, why would the flow of electrons from NADH to oxygen, why would that stop just because of the lack of ADP?
Because the hydrogen on either side is too strong.
Yes, exactly right. So, electron transport moves along, and at each step, if you're going to transfer the electrons here, if it goes up Q, you must pump protons. Okay, there's a certain amount of power in the redox potential of NADH. It can push out a certain number of protons. But it gets increasingly difficult to pump protons if you've got more protons out there. So the bigger the gradient, the harder it is to push out the next proton. So if this gets really acidic out here, it becomes too hard to pump the proton. And the electrons just aren't going to flow because they have to pump protons to do this reaction. So the bigger this gradient, the slower the rate of NADH oxidation. And why would the gradient get big? If you stop this process, this is the only way for protons to complete the circuit and go back inside. If you block this off by stopping this engine, then the gradient just gets bigger and bigger and bigger until it reaches a point where these guys just can't pump out any more protons. It's just too hard. And so the electron flow process grinds to a halt, or at least to a very low level. So you're not going to oxidize NADH unless you've got some ADP that needs phosphorylated. And that's very important physiologically.